Hello everyone. Today I'm going to explain this project called FSM COUNTER, which we designed and implemented Quartus Prime using VHDL on the DA10 Lite FPGA board. So let's start with the VHD file. So in this code we created an entity called FSM COUNTER, which has several important signals. The clock 15 MHz, which contains the clock input from the FPGA. Reset clock is used to reset the clock divider, and reset is the input that restores the FSM back to zero. The outputs are clock out, which is the divider clock, and count, which represents the binary output of the current state, and seg anode, which represents the 7-segment display. So inside the architecture, we use a 26-bit counter to divide the 15 MHz clock and obtain this a slower signal that we can observe on the board. Then we define 10 states from 0 to 9. Each state has its own binary output value and its corresponding 7-segment display pattern. The FSM changes from one state to the next on each rising edge of the divided clock, and after reaching 9 it goes back to 0. This structure makes the circuit behave like a digital counter that continuously cycles through numbers 0 to 9. Next, we have the BH 0 to 9. So next we have the BHD file, which is the test bench used for the simulation. Here, a clock signal is generated by alternating logic levels every 10 nanoseconds, simulating the 15 MHz clock. The test bench connects all ports of the main entity and allows us to observe the signals, like count and seg anode, in the waveform during simulation. This helps verify that the state transitions and 7-segment patterns are correct before implementing them on the hardware.
Sí.
So finally, in the pin planner, sorry, it's not this. Well, it's the assignment editor, but it's the same for the pin planner. We assigned the FPGA pins for all inputs and outputs. So for example, 15 MHz clock is connected to pin 11, pin P11. The divided clock output is on pin P11. The reset signals is on pin A12, and the 7-segment display outputs are connected to their respective pins. These assignments ensure that the design works correctly with the physical hardware of the DA10 board. So let's see how it works in the FPGA. So here we are in the FPGA, and you can see the FPGA is counting from 0 to 9. And when it reaches 9, it starts with 0 again. So you can pause it with switch 0, and you can return to 0 with switch 1. And that's it. Thank you for watching, and see you in the next video.